Okay, so for the second version of the test, let's see, I'm seeing a polynomial first off. I see it opens down, so I know the leading coefficient will be negative here. Let's see. And what else do I see here? I see there's a 0 at x equals -2. I also see it bounces, so it's a double 0. Nothing special happening at -1, but you see how at +1, how it wiggles through the graph. So I know I'm going to write x plus 2 squared because it bounces. Nothing happening really at x equals -1, so that'll just write x plus 1. And of course, it's wiggling through the x-axis at x equals 1, so that's going to be x minus 1, and that has to be cubed. I also see that it has a y-intercept of, let's see, I think on the test I told you that that was 4/9. I hope you know by now that when you see a repeating 0.44, that's 4/9. So there's a stretch factor going on here. So if y equals 4/9, that's equal to some stretch factor. Now we're going to drop in 0 in for x. So 2 squared is 4. 0 plus 1 is 1. And -1 cubed is -1. So that's going to give me 4/9 equals a times -4. So if we divide by -4, multiply by -1/4 is the easier way to think about this. I see I can cross cancel that 4 out, replace it with 1s. So a is -1/9. Okay. Next question. I spy with my eye. What do I spy? I see a vertical asymptote. I do not see it. See, the function is not defined over here to the right. So I know it's not a rational function, because rational functions are defined. They have the vertical asymptotes, but they're defined over the rest of its domain, right? And this just has a limited domain. So I know it's a log function. I see a vertical asymptote. I think it's happening at x equals 2. Let's see, yeah, the scale is 2. Every line's worth 1, so the scale is 2. So I'm going to write y equals some stretch factor times the log of. And the other thing I see, normally log graphs head off in this direction. So this has been reflected around the x-axis, which is going to make a negative, but it's also going to reflect around the y-axis because it's not heading off. I mean, if we just reflect around the x-axis, it would look like that. So I know inside has to, remember how f of -x makes it a function reflect around the y-axis. So I'm going to write negative log of negative, and then of course we see it's shifted right to, so x minus 2, then plus k. And of course I'm going to clean this up a little bit inside. I'm going to write y equals a times the log of -x plus 2. That'll make our work a little easier here. Now I'm going to test, I know this graph crosses through the point 1, 0, so let's see if there's any kind of, has it been shifted up or down? So 0 equals a times the log of, well, if x is 1, -1 plus 2 is 1 plus k, and we know the log of 1 is 0, so this is gone, 0 equals k. There's no up-down shift, which we were hoping. In fact, most of these problems in this textbook series don't have any up-down shifts. And then we get this other point, -7, -10. So this will help us find the stretch factor. So -10 equals some number a times the log of. So then we see -7, and -7 turns to +7. And then 7 plus 2 is 9. And the k is gone, we know. So divide by a, so -10 over the log of 9 equals a. So that's an answer. We can also write this as, it doesn't get us anywhere, so I'm not going to show you the other way to write this. So, I mean, it's like we can cancel anything. So, well, maybe I should talk about that. Log 9 is same as log of 3 squared. I can bring the 2 in front. Oh, maybe we can cancel this half a little bit. So bring the 2 in front. So negative 10 times 2 times the log of 3. So we could simplify that down a little bit. Think of the a as negative 5 over the log of 3. But the other equation works too. So y equals, since I've done this work, I'll use the new one. Negative 5 over log of 3 times the log of negative x plus 2. And of course, we know k is 0. And remember, log of that argument divided by log of 3 is just a change of base. So I could write this as negative 5 log base 3 of negative x plus 2. And that would work. Okay. And then we get a parabola. So this is a quadratic equation. I see the vertex is negative 1, negative 2, so that's the easiest way to write this. Y equals, I don't know, times x plus 1, because it's minus the x, squared, plus the vertex, the y of the vertex. And this has probably got some stretch factor. So I'm going to say 0. I'll use 0, 0. 0 equals some stretch factor times 1 squared minus 2. Well, if I'll add 2, and 1 squared, of course, is 1. So a equals 2. And of course, that makes sense. It's been opens up. We could also think about this. Normally, parabolas go over 1, up 1. And this is going over 1, up 2. So that's another way to come up with that stretch factor for this question. All right, so for this next problem, I see, okay, what do I see? I see a couple of vertical asymptotes, and I see a lot of domain where the graph is functions happening. So I know this is a rational function. I see a vertical asymptote happening in it too. So I know vertical asymptotes go in the denominator. And I see another vertical asymptote at negative 2. Or maybe it's not negative 2, maybe it's negative 1 now that I'm looking at it. So it's going to be x plus 1. And then because this is acting like 1 over x squared, because they're both headed in the same direction, I need to square that. I think on the test, I tweaked this and said there's a hole at x equals 3. So if that's the case, we've got to put a x minus 3 on top, x minus 3 in the bottom. That way they cancel off. It's not a vertical asymptote, but 3 is not in the domain. Now, let's see. What about zeros? I see it crosses the x-axis at 0, 0. So x plus 0, I'm just going to write x. I also see that it touches the x-axis at 1, but it looks to me like it bounces. So I'm going to write x minus 1 squared. So I see same x cubed on top. Well, if we ignore the x minus 3. I see, well, x to the 4th on top in that case, and x to the 4th on the bottom. So they're the same degree. So it must be there's a horizontal asymptote. And I think it's this line right here. I think on the exam I wrote it, I gave that to you. So I see that's negative 1. So that's the horizontal asymptote, negative 1. And we're done. Okay, in this function, I see a horizontal asymptote. I don't see any vertical asymptotes. This is a transformed exponential function. I see that it's been shifted up now. See every line's worth 2 here because of the 10. So I know it's going to be y equals ab to the x plus 2 because it's been shifted up, up 4. I can't count. 2 lines, every line's worth 2. That would make it 4. And then let's see if we can eliminate one of these variables. So I know it passes through 0, 6. So 6 equals a times b to the 0 plus 4. Well, b to the 0 is 1. That's 1 times a. And then I'm going to subtract 4. So a is 2. So we know it's going to be y equals 2 times some number to the x plus 4. And then we can use this other value, the 22, negative 22. So 22 equals 2 times b to the negative 2 plus 4. Now I want to isolate that b to the negative 2. So I'm going to subtract 4. I think that gives me 18. And I'm going to get rid of that negative exponent right now. So now I just have a proportion. I'll do the cross products. So b squared times 18 equals 2, so doesn't b squared equal 1 over 9? And if we take the square root of that, b equals 1/3. So y equals 2 times 1/3 to the x plus 4 is what that is, a function that represents that graph. Okay, now we're down to this radical, and I see zeros. I know it's 0 underneath at -2 and at +5. Now I'm just going to pick numbers either side of this. If I go really negative, doesn't matter. This one will be positive, but that'll be negative, so it's a negative answer. If I pick a number between -2 and 5, like 0 works, that'll be positive because it's getting squared, and that'll be positive. And then if I go a number bigger than 5, well, everything's positive. So what's the domain of this function? Well, from -2 until 5. And I'm sorry, not until 5, to infinity. Because the -5, it's equal to 0, and that's not a problem. And it's closed at -2. All right, so that's that graph. That's that domain with the analysis. And then the last question for this version is talk about Hillary. Let's see. So how high is the bagel? Well, we know it is at h of 0. That's the initial release. That's 0, so it'll be 20. So it's the y-intercept some of you mentioned. What's the maximum height it attains? I see a parabola that's going to open down because that leading coefficient is negative. That tells me the vertex will be the maximum value, or the y-coordinate of the vertex will be the maximum height. So then to do the analysis, you got to remember that x, or t in this case, equals -b over 2a. So -50 over 2 times -16. Let's see, I believe that is, let's see, where's my work? Let me find this problem. This is about Hillary, right? I'm not seeing it. I guess I'll just do it out the long way. I'll make the video a little, oh, here it is. I got 1.56 seconds. 1.56 or so. And then seconds. So that's when it happened. Some of you are getting confused with the units. So that's the time because it's t. And then to find the height, we're just going to evaluate this function, this h function, at 1.56. So, I mean, to do it at the long way, you're just going to write it in. You didn't have to show this. Writing this would have been sufficient because I would have hoped that you knew to do that. I mean, plus 50 times 1.56 plus 20. And then you just evaluate that in your calculator. And I got, let's see, I got 59 point, I guess, 59.1. I don't know. Am I doing this right? Just a minute here. Oh, yeah. I'm looking at the next question. So 59 point, so it's about 59 feet up. Okay. Now for the very last question, what I'm looking for is when does that bagel splash down? So we're not looking for h of 0. We're looking for when it's equal to 0. This is a quadratic equation. What you do is you set it equal to 0 to solve quadratic equations, right? Then you'd either, we know how to solve quadratic equations 3 ways. Some of you were moving 20 over, then doing some math magic. Quadratic equations, we set equal to 0. We try to factor. If it doesn't factor, we use completing the square, which no one ever does anymore, or we use a quadratic formula. To use a quadratic formula, you got to remember that the leading term and just the coefficient. So a is -16, b equals 50, c equals 20. Now, this isn't going to have an imaginary answer. We know it's not because it's an upside down parabola. It's going to cross the x-axis. So this is a situation where quad 83, using a polynomial solver, works really well. Now I've got my calculator up here. If you use one of my calculators in class, or if you have a graphing calculator, the way you access the, let me move this out of the way a little bit so I can see it a little better. I guess that's close enough. So I'm going to clear this. I'm going to clear out this so you can see this, see what I'm doing. So I'm going to press program. Now you're going to have, if you use one of my calculators, you're going to have a couple more programs on this. You want quad 83. So I'm going to type a 1 because that's the enter, that's the function that's there. You can just hit enter, or the program that's there, or you can just hit enter. Then I hit enter again to get it running. Then it prompts me, what's A? Well, A is negative 16. What's B? 50. What's C? 20. Whoops, Dan LeMay, you messed this one up. Yes, quit. You probably noticed that. Quit. So program, the nice thing about it, it's easy to fix. So A is what? Negative 16. B is 50. Let's do it right this time. And then C is 20. And we're getting at 3.4 seconds. It's a heck of an arm to keep that bagel aloft for almost 4 seconds. So that would be that solution. So all I was hoping you to do is to either write the h of t equals 0, and then you can just write the answer. I'm assuming you use some solver for it. I encourage you to use some solver for it. This is an algebra 2. Okay. So that is that version of the test.